right, so the good news is you know how to do everything that we're going to do with this lesson. We've been working on finding moles with solutions, going from their concentrations. You know how to do stoichiometry and BCA charts. For this lesson, it's just putting those two things together. Excuse me. And so we'll mainly, again, go through some practice problems with you and then just let you go and practice and bring your questions back to our regular meetings when we do get together. So let's just get to it. So stoichiometry with solutions. Again, the thing that's different about this from the other stoichiometry that you've been doing is you're just going to use your concentrations to figure out the moles. And you've been practicing with that, both with molarity and with mass percent. You could do it with those other concentration units that we mentioned, but we're going to just stick to these two. Once you get those moles, stick it into a BCA chart, and everything else just flows from there just like normal. So we'll work through a few, and as always, if you feel like you can go ahead and skip to the practice problems, I don't have any problem at all with that. If you do get stuck on the practice problems, you can always come back and watch some examples as you need to. I try to cover everything that you'll see in those practice problems pretty much. So we'll just get started. So what volume of 0.25 molar sulfuric acid, which is H2SO4, would be required to neutralize 5 grams of potassium hydroxide? So I'm doing stoichiometry. The first thing I'm going to do is write a balanced equation. So I've got sulfuric acid, which they gave me the formula, and potassium hydroxide. And so I'm writing my formula. We learned how to do that a few weeks ago. So potassium's +1, hydroxide's -1. So they combine in a 1-to-1 ratio. And this is a double replacement reaction. This is an acid, this is a base. So I'm going to get the salt, potassium sulfate, K2SO4. I have 2 potassiums because sulfate has a -2 charge. Takes 2 potassium to balance that out. And H2O is water. So that's the H from the sulfuric acid and the OH from the base, making a water molecule. And so I need to balance my equation. As we've said, it's usually easiest to start with your metal. So I've got 2 potassiums here, only 1 here. So put a 2 there. And then go to your non-metals. Sulfur is good. Always save hydrogen and oxygen for the end. So for the hydrogen, I've got 2 + 2, which is 4. On this side, I only have 2. So I'll double that. And then oxygen hopefully falls into place. I have 4 + 2, which is 6. I have 4 there, +2 there, which is 6. So we're ready to go to the next step. All right. What I'm given is 5 grams of potassium hydroxide. So as always, I can only use moles in my BCA chart. So I'm going to come down here and figure out some molar amounts. So 5 grams, and this is KOH. So I need to convert that to moles. So go to my periodic table. Potassium is 39.098, so I'm going to call that 39.10, plus oxygen, you probably know all these by now. Oxygen is 15.999, so I'm going to round that to 16.00, and hydrogen is 1.01. So 56.11 is my molar mass. So when I divide that, I get 0.08911, 3 sig figs, 0.0891. And that's the number, wrong place, the number of moles, 0.0891 moles of the potassium hydroxide. So that goes in my BCA chart right there. Now, I'm looking for the volume of this one. So I'm going to do my stoichiometry calculation. It's a 2-to-1 ratio. So I'm going to divide this number by 2, multiply by 1. Of course, it doesn't change a thing. So 0.04455, so 0.0446. is the number of moles of sulfuric acid that I need. And that's really all I need to do with the BCA chart, because this is going to be what I need to answer the question. I need a volume of acid, I know how many moles I need, and I know a molarity. So we haven't really looked at calculations quite like this before. For this, probably a proportion is the easiest thing to do here. I'm going to come down here and separate this out. So we talk about molarity, we use the big M as an abbreviation, but for these types of calculations, it's really better to think about it as 0.25 moles over 1 liter. And that helps you see the proportion in this. So the solution has this concentration, but I don't need 0.25 moles. I need this number of moles. So 0.0446 is the number of moles that I need for this reaction. And I'm going to solve here for X. X is my unknown, and that's going to be the volume. So 0.25 liters is to 1 liter, as 0.446 is to X liters. So cross multiply and divide. Do y'all still do that in math? So 0.25X is equal to 0.0446. And then solving for X, I'm going to divide both sides by 0.25. And I get 0.1784. Two sig figs there because of my molarity, so I'm going to round that to 0.18. And this is going to be in liters. So that's your answer. It takes 0.18 liters. We usually think about things in the lab in milliliters. So multiply by 1,000. You don't have to do this, but if you did ask for milliliters, either one of those answers would be fine if it didn't specify. But I usually think about things in milliliters in the lab. But again, either answer is perfectly fine. Lost my bottom of my L there. Alrighty, so that's a little more complicated, not a whole lot more. Stoichiometry is just the same, 2-to-1 ratio, but you usually have to do a little something else with it after you get that initial answer. All right, we're just going to keep on trucking through these. So next question. What mass of silver would precipitate when 36.4 milliliters of a 0.45 molar solution of silver nitrate reacts with excess copper? And just as a hint there for your equation, copper 2 nitrate is the other product. This is a single replacement reaction. So silver is precipitating, so that's going to be a product over here. And it says copper 2 nitrate is my other product. I'm reacting silver nitrate and copper. Silver, if you'll remember, is one of those transition metals that doesn't need a Roman numeral because it's always +1. Nitrate's -1. And this is solid copper here. So in a BCA chart, I need moles, and I'm looking for the mass of the silver, just so I kind of know what I'm doing. Nothing here gives me moles. Nothing here gives me mass in what I'm looking at, but I have a molarity and a volume. And this is the most common calculation probably that you're going to do with moles and volume. So 36.4 milliliters and 0.45 molar solution. I'll just turn this sideways here. So like I said before, it's probably easier to think about your molarities as moles over liters. And I need liters to cancel out. So if I multiply this fraction, this concentration, by something in liters, I can cancel that out and I can have moles. So I need the volume, which is 36.4 milliliters. I need liters. So I'm going to move my decimal 3 places. to the left. So my new decimal is there. So it's 0.0364 liters. And just kind of get comfortable with doing those, oops, not times, equals, doing those milliliter liter conversions. You'll have a lot of them. So 0.45 times 0.0364 equals 0.01638, 2 sig figs, so 0.016. So that is the amount of my silver nitrate, 0.016 moles. And now I can do the rest of my problem. Oh, no, I can't, because I did not balance my equation. Silver's good, copper's good, nitrate is not good. So I need a 2 there, which changes this. And then it looks like I'm balanced. Alrighty. So this is a 2-to-2 ratio of silver nitrate to silver. So if I'm using 0.016 moles, I'm going to produce 0.016 moles of silver. The question asks me for mass, so I do have one more quick little step, and that is to convert the the moles of silver to a mass. So 1 mole of silver is 107.87 grams, I think. Maybe I should check that. 107.87. And so I get 1.73 for my mass of silver. So there's my final answer. So with this one, the different thing is how we found the moles to go in the BCA chart. And again, this is a really common calculation and conversion that you'll do. The molarity times the volume is going to give you the moles. So I'm going to stop this video here. I'll just post several videos in succession of all these little practice problems that we have to work through, just so you'll have plenty of chances to watch and learn. So as always, when you feel ready, you can start doing some practice problems, and if you get stuck, come back and watch a little bit more of the video. So I will see you soon.